Hi, judges. My name is Jeff Mao, and I'm a senior at Lambert High School. Today, I'll be discussing my poster on HPCC Systems on the Google Cloud Platform, and my mentors are Xiaoming Wang and Gaussen Fortil.
The goals we had over the duration of this project were primarily aimed towards establishing HPCC systems onto Google Anthos while leveraging and taking advantage of all the features that Google Cloud offers. The list of goals we had for this project include creating Kubernetes clusters on the major cloud platform providers, registering those clusters, installing config management, installing Istio, and evaluating Anthos service mesh and along with evaluating the various logging, monitoring, and metrics tools provided for users to use. What is Anthos? Anthos is a modern application management platform. It's an umbrella that encompasses many different services which are directed towards the cloud. It is open source and based off the Google Kubernetes engine. Listed here are the Anthos' building blocks. It consists of Google Kubernetes engine, GKE on-prem, and Istio. All three work together to build the backbone of Google Anthos. Also depicted in the diagram above, you can see how Anthos manages multiple clusters and funnels it under a singular management platform. This is despite them all being under different cloud platforms. The Anthos Service Mesh is basically a suite of tools that aid in monitoring and managing your clusters. ASM comes with a network traffic manager known as Ingress. The Ingress Gateway allows HPCC users to set rules for inbound traffic. This can be used on traffic headed towards ECL Watch. An example of this would be directing 80% of network requests to a stable version of ECL Watch, while 20% of network requests get directed to a new release of ECL Watch. The Anthos config management allows HPCC systems to manage many different types of Kubernetes clusters by utilizing config files stored on Git repositories. It enables configuration as code on multi-cloud environments, which benefits HPCC users because it allows them to set unified network and security policies across multiple applications. As you can see in the diagram below, Anthos syncs the state of 3 HPCC clusters using a Git repository here, despite them all operating on different cloud providers. This is a huge benefit to HPCC systems users because it allows for the creation of thousands of clusters without requiring the thousands of configuration files. Anthos also comes with a variety of telemetry tools to aid users in understanding their application. It also comes with several third-party programs in the box. These are Grafana, Keali, and the Elastic Stack. Sadly, I was not able to evaluate the Elastic Stack because of time constraints, but I was still able to evaluate Grafana and Keali. These third-party programs are beneficial because unsupported cluster types such as Azure Kubernetes clusters and on-prem clusters cannot utilize the tools that Anthos provides as a default. These third-party telemetry systems greatly benefit HPCC users by providing a central place to view logs and metrics and to debug their applications. Anthos' benefit to HPCC systems is immense. Development-wise, Anthos supports Git-compliant management and continuous integration / continuous deployment workflows for configuration as code through config management. This allows HPCC users to follow industry best practices without necessitating expensive development time. Anthos supports the implementation of clusters onto existing hardware through Anthos on-prem. HPCC systems can take advantage of this by using its own data centers to host sensitive Kubernetes clusters. Anthos' flexibility is also another trait that greatly benefits HPCC. Anthos gives its users a choice in which cloud provider they choose. It provides a single platform to manage all these applications. It also increases productivity through the reduction of development time. Finally, it creates consistent and unified security policies across all major computing platforms. This prevents costly security breaches and potential downtime, saving HPCC systems users millions in damages. In conclusion, as HPCC Systems is moving towards native cloud development, users will experiment with multiple cloud environments. Using Anthos, HPCC users will be able to benefit from a streamlined process in which all cloud environments are packaged and managed under one singular application. However, there are still some issues regarding Anthos and its components. For example, with Istio Sidecar enabled, HStore, Roxy, and Thor jobs will never finish. This is due to a long-standing Kubernetes bug. I also experienced issues setting up ASM, which were unfortunately never resolved. All in all, Anthos is a new technology and has a long way to go before it should be used in production for HPCC users. However, despite all this, it shows a lot of promise. Finally, I have my resources provided below if anyone is interested in my project and would like to follow up on it. Thank you for listening to my presentation.